So dear students, today we are going to discuss about the redox titrations. As we had discussed in the last class about oxidation reduction reactions, that there are that many of types of chemical reactions. Okay, acid-base precipitation, solubility means complex formation, oxidation reduction reaction that we have discussed. The oxidation reduction reaction means there is the three methods based on the one is the based on the oxygen. Any compound that accept the oxygen that is get oxidized. Any compound that accept can say that then that can donate the proton, that is called as oxidations. And any compound that can lose the proton, that is oxidation. Reduction, any compound that can lose the oxygen, and that can accept the proton and that can accept the electron, that is the reduction. So that is the oxidation reduction definition that we have discussed, and both reactions that is takes place in the same reaction, that is called as the redox reaction. Okay, so that we had discussed in detailed way, and so that is the oxidation reduction that I have discussed with you in detail. So today we are going to start about the titrations, oxidation reduction titrations. Okay, we can also discuss that we have also discussed that how we can ascertain oxidizing the states, like any metals or any compound that having the zero oxidizing states. When it get be oxidized, then it can say it may be convert into the ions, then the oxidizing states can be come in scenario. Okay, say for example Fe+3 have oxidizing state 3, but Fe does not have any oxidizing state is 0. Okay, so that we have discussed about rule and all and oxidization practice that I have discussed with you, that how we can determine the oxidizing states of sulfur in potassium sulfate, sodium sulfate. Okay, oxidizing states of iron in ferrous oxide and ferric oxide and all. Okay, so that we had discussed, and we had discussed the how we can ascertain, how we can determine that oxidizing reactions, what is the oxidizing reactions and which is the redox reactions. Okay, that is the decomposition reaction, composition reaction, that all are we had discussed types of oxidizing reactions. Okay, displacement reactions. So here like strontium and water, that can be strontium hydroxide can form, and that is also oxidation reduction reaction. Hydrogen that is displaced, titanium chloride, magnesium, that metal displacement, hydrogen displacement, all are displacement reactions. Okay, and hydrogen displacement reaction that we had discussed number of reactions, like calcium hydroxide get is formed. Copper demonstrations also, that is in this category. Okay, disproportion reactions that come under the oxidation reaction like chlorine react with the hydroxyl groups, and that ClO minus that is formed, it's oxidation reaction again. Oxidation and reduction reaction that is takes place, oxidation reduction. Yes, these are the number of the reactions that we can classify, like calcium and carbonate, the calcium carbonate that is formed, ammonium and hydroxide, ammonium hydroxide. So these are oxidation reduction. One species get oxidized, another is get reduced, like calcium oxide that get reduced in calcium plus is reduced in calcium. Okay, and CO3 2 minus that is reduced into the CO3, so that is calcium oxide, that is oxidation state is 0. Okay, so that similarly all are that we have discussed. One is the half reactions, and half reaction that is reduction, half reaction that is the oxidation. Okay, so that we had discussed. Look at here like SO3 and S plus and MnO4 minus, that will be SO4 Mn plus 2. So that is the what happened, MnO4 minus that is get oxidized in Mn plus 2, and SO3 minus that get oxidized into the SnO4 minus. So that is the things that we had discussed. The balancing, yes, we can also balance in the oxidation reduction reactions by making you can say using, you can say, oxygen and all, that can be a balancing part. Electrons we have to be balanced. Okay, we have to manage that. Might be you have discussed in your school level as well, balancing reactions. Okay, like how can manage balance ions and these all things. Okay, so we can take one example like MnO4 minus and Fe plus. So look at here, we can balance it. One get Fe plus 2 get oxidized into Fe plus 3, Mn that is oxidized, reduced into Mn plus 3, that is reduced into the Mn plus 2. So that is happening. Okay, so now we are after the discussions about the redox reactions. Now we are discussing the redox titrations. So titrations means redox titration means the Yes. Okay. So back redoximetry titrations, the application part of this, that magnesium oxide that can be reacted with can say oxalic acid, and what will happen, that magnesium Mn+2 that will be converted. Okay. Displacement redoximetry titrations, that displacement redoximetry titration, what happened, that one iodine, this like iodine that is reacted with the thiosulfate solution, sodium thiosulfate solution. So what will happen, that iodine can be displaced. So displacement, that displace of iodine can be displaced by the thiocyanate. So that is called the displacement titration, that redox reactions. Okay. And titration curve in redoximetry titrations, yes, one get oxidized, another reduced. So what happen, it is based on the next equation, we can get a redox, you can say curve. This is the curve that we had discussed also previously. Okay.